Okay, hello everyone. This is Finderpin from Treble Technologies. I'm really excited about today's webinar. I'm excited to be showcasing some new and very cool features in the Treble Acoustic Simulation Suite. Okay, there's actually quite a lot I want to simulate here, and time is limited, so I will try to go as fast as I can so I can cover everything. First, I want to give just a very brief overview of the Treble Acoustic Simulation Suite. I'm sort of assuming that most people here on the call are familiar to some extent with our software, but just in case there is someone brand new, then I'll spend 30 seconds giving a very high-level summary of the product. I'll then just spend 2 words talking about a very exciting upcoming event in October, which is the launch of Treble's second product, the Treble SDK. And then move on to the main part of the presentation, which is showcasing a bunch of new features and improvements. First of all, the ability to import loudspeaker data in the CLF format into Treble and be able to simulate the interaction between loudspeakers and rooms, and also showing our new loudspeaker database, which is growing these days and will be growing over the coming months. Some very cool features relating to auralizations, being able to set up a particular auralization and save the settings that you set up, and then revisit them later, compare different setups that you have set up, and be able to share your auralizations with collaborators, clients, and so on. Not less cool is improved geometry processing, being able to import less perfect models into Treble, room models, and work with them further. The ability to compute open office parameters, such as distraction distance and things like that. A feature which we internally here at Treble call auto stop. Maybe a more precise name would be something like energy threshold termination of simulations. I'll show what it is, and it's a really cool new feature which improves efficiency of simulations. A neat little feature, being able to copy parameter results from Treble directly into Excel with just one click, and some small UI improvements here and there. And then we will move on to the Q&A part of the webinar. So without further ado, Treble, the platform, is a platform of virtual sound, meaning it's a piece of software that can do sound simulation on the one hand and sound rendering or auralizations on the other hand. And the sort of centerpiece of our platform is our proprietary simulation engine, something that we're very proud of and have worked on, or is the fruit of many years of R&D, where we are combining wave-based simulation methods for low to mid frequencies and pressure-based geometrical acoustics for high frequencies. And this engine allows people to do more accurate and more efficient acoustic simulations than what has been previously possible. The platform is then structured in this way. The simulation engine is based in the cloud, which offers a lot of flexibility and scalability. And then we are essentially building 2 interfaces to this simulation engine. On the one hand, the simulation suite, which is the product I'll be talking about mostly today, a graphic user interface tool to design acoustics. And on the other hand, the SDK, which is more a programmatic interface to the simulation engine. Now, the simulation suite itself. There are a number of use cases that this tool is suited for. From the get-go, we have perhaps mostly been focusing on room acoustics and architectural acoustics design. This is certainly one of the main use cases. But now, from today, we are launching some very powerful capabilities to be able to model sound systems in the product. It sort of marks our first step into the world of electroacoustic simulations, which we will then continuously be improving over the coming months. Treble or the simulation suite is also suited for outdoor sound simulation. Maybe not at the level of sort of doing noise mapping of an entire city, but more sort of local projects, such as analyzing the acoustics and noise in a building site, shaping buildings to improve acoustic conditions in the local environment, urban acoustics, designing traffic noise barriers with great precision, things like that. And then we have some really powerful auralization capabilities as well, which allows people to set up and design soundscapes, not just acoustics. And what we're trying to bring to the table with this product is essentially 3 things. First of all, better accuracy of simulations, which in turn reduces risk, improves confidence, avoids over-design, things like that. And this is brought about through our sort of state-of-the-art simulation engine. And then secondly, a very strong emphasis on making the whole workflow around working with acoustics and doing simulations more efficient and seamless. The whole thing is based in the cloud. You can run simulations from any device, run as many simulations as you want simultaneously. You can collaborate with colleagues, try to have a very nice user experience, user interface, and so on. And then last but not least, because we can do very accurate acoustic simulations, then we can also do perceptually authentic auralizations. And we're also just trying to make auralizations more interactive, immersive, and just more fun. The way it's structured now is that the simulation suite is live linked to SketchUp. So we have a plugin in SketchUp that connects the two tools. But soon we will be launching plugins and connections to other 3D modeling tools such as Rhino and Revit. So please stay tuned for that. Okay, that was the simulation suite. Just wanted to say one thing here about the SDK. We are launching it officially on October 17th. So please mark the date in your calendar if you're interested in this. This SDK is useful for many exciting things. For example, setting up thousands of scenarios to generate a lot of audio data or acoustic data, which you can then use to train all kinds of machine learning algorithms like speech recognition or de-reverberation. Being able to do more advanced acoustic analyses, integrate our simulation engine into third-party software tools, and do parametric studies, for example, setting up from a scripted input thousands of permutations or of receiver positions or materials or things like that. Okay, that was the SDK. Now moving on to the main part of the presentation, showcasing these new features and improvements. And I'm going to move over to the Treble Simulation Suite now. Okay, here I am in the simulation suite, and I'm going to play around with this open plan office model today. A couple of minor UI improvements already seeing here. For example, these little nice buttons here that allow you to directly access or the Auralizer or results, and also kind of a more direct access to resources such as tutorials and so on. And I also remind of our live chat, which if you're running into any problems or any questions, please write us there and you'll get an answer very quickly. Okay, I'm going to open this open plan office model here. And the first thing that I'm going to show you is our new loudspeaker modeling capabilities. So I've set up a simulation here. I'm going to move this guy over here. I've set up a simulation for this room where I've assigned some materials and scattering coefficients and so on. Then I put in a couple of omnidirectional sound sources and some point receivers in the space. And what I want to do now is change these speaker sources from being just omnidirectional to being some particular loudspeakers. So I'm going to click this button here, and then I open up our loudspeaker library. And it's decently sized already, but we will certainly be growing this over the coming months. We are in dialogue with many of the biggest loudspeaker manufacturers these days to get their data into Treble. And I'm going to, for example, place a ceiling speaker here in this position here. So I'm going to categorize and just show ceiling speakers. For example, just choose this QSC speaker. I can look at the directivity patterns and things like that here. And I'm just going to go ahead and assign this speaker here. And for the other source position, maybe just have that be some kind of a Marsden audio speaker. Why not? Maybe this one here. Okay. Now I've kind of introduced two loudspeakers into this room, and I can do room acoustic analysis with these speakers in the room. I can do auralizations and sort of assess the interaction between the speaker and the room. I could also import my own loudspeaker into the tool if it isn't in the database. Let me show you quickly how this looks. Then I go here and import a directivity pattern, drop it here, and it gets into the library. Simple as that. Okay, now I'm going to run the simulation and also show you another really cool new feature, which is this auto stop feature. So typically when people do room acoustic simulations, they need, up until now, have needed to kind of set the impulse response length of the simulation, how long of a simulation impulse you should simulate. This means that you kind of have to guess beforehand roughly how long you think the IR is going to be. If you put it too short, and sometimes you don't get, for example, the T30 reverberation time values because you don't have enough energy decay in your impulse response to calculate T30. If you set it too long, then you may be simulating something that you don't really need. The energy decay from -50 to -60 doesn't really give us any information. So it's kind of waste of compute resources and time. But now with Treble, you can just say how much of an energy decay you want to simulate, and then we simulate up until that point and terminate the simulation there. So for example, saying I want a 35 dB energy decay, that means that that's enough to compute T30. If I'm in a bit more of a hurry, I can say, just 25 dB, and then I can compute T20, but not T30, and so on. So that's a very nice new feature. And I'm just going to fire off this simulation here. It does tell me roughly how long the IR will probably be, but the energy decay will dictate that exactly. Now a machine is spinning up in the cloud to run this simulation. And I'm going to come back to this simulation and these results in just a second, do some Auralization stuff with it. So I'm going to create one more simulation, duplicating this simulation that I just set up. So Acoustic 2. And I'm just going to change the ceiling material here to a concrete ceiling, just to have a bit of difference when we do Auralizations later. Otherwise, I keep everything the same and just fire this one off. All right. While we wait for this, I want to show you a couple of other really cool new features. So I'm going to go to a different simulation here and show you these open office parameters. So the open office parameters are measures of acoustic comfort in open plan offices. And open plan offices are one of the trickiest space types to do acoustic design in. And the way the standard specifies working with this, the ISO 3382-3 standard, is that you set up a sound source and then you set up sort of a line of receivers, and then you compute these parameters from kind of assessing the results across these different receivers. Now, I have already run this simulation, so I'm just going to go directly here to the results. Move this guy over here now. And we see a new parameter here, OOP, Open Office Parameters. If I click it, it actually shows nothing. That's as expected because I'm just showing the results for one receiver now. But if I add additional receivers, I'll just add all the receivers, then it can compute the open office parameters across these receivers. I'm going to add a comparison here. And that be for all the receivers as well. This one here was open office 2, had an acoustic ceiling, whereas this one then had, a concrete ceiling. And what we see here in the results, obviously by adding the acoustic ceiling, we increase the distraction distance, we improve how fast speech is decaying over distance, the sound pressure level of speech is lower, etc., as one would expect. We can analyze this for different background noise levels and so on. So a very efficient, simple way to analyze open plan office parameters in Treble. Okay, the next feature I want to show you is just a neat little feature, but still I'm a big fan. It's this notion of being able to copy results from Treble and, for example, into Excel if you want to work with them there. Now, we have tried to build a very nice user interface to analyze results and so on. You can also save the pictures, and compare results and everything. But sometimes you still just want to convert these or copy them into different tools. And we've had from day one the ability to download results where you get the impulse responses in an Excel sheet with all the parameters and so on. But now it's just a little quicker way. If you just want these parameter values, you just click this little button here. They're copied to the clipboard. I go to Excel and I've set up this little template here with some kind of graph. And I just paste Control V here, my results in here. And now I have them in Excel. I have 2 lines because I had 2 simulation comparisons there. If I had more, then I would have more lines, or if I just did the one, then I would just have 1 line. So a very easy way to go from Treble to Excel. Okay, now I'm going to go back to the simulations I was just running before and show you some really cool new Auralization features. So let's take a look. Here we go. These simulations are done. I'm just quickly going to refresh here and go to the Auralizer. So, as I'm sure most of you are familiar, in the Auralizer, we can listen to the space. We can jump between different receiver positions. We can compare different simulations on the fly, for example, different material configurations of different models and so on. We can select different sounds on the fly. This has been available all along. But now we're introducing this little button here that allows us to save some kind of setup of an auralization that we have done and compare them between each other and also share them externally. So let me just create a little auralization here, maybe put some drum loop and these boys talking here. If I play here, this is the dry sound. Then I go into the space. Now I'm hearing the space with these particular loudspeakers in them. And then I can go here and I can save this little setup, maybe just for fun. Let me just modify things a little bit, something like that. And then I can save it here. I'll call it Drums and Boys. And then I can modify something. Let's maybe, oops, I'm not going to do that. Let's maybe change this to jazz here. And then I'll save that one as maybe modify the volume a little bit, because why not? And I'll save this one and I'll call it Jazz and Boys. And now I can compare them on the fly. Which is really nice and really useful if you want to come to the auralization later, for example. And last but not least, the ability to be able to share the auralization. I've now set up this particular auralization. I've carefully crafted my auralization, and I can either input an email here, like my own email, then click the button, and then I will be sent the link, or I can just copy the link to the clipboard and send it to someone. And what the person on the receiving end will then receive is basically a sort of read-only auralization here. They cannot modify the settings or so on, but they will basically get a view that looks something like this, where they can basically hear the auralization, flip between different design options, flip between different receivers, and so on. Almost all of the features I'm showing today are launched or are about to be launched within the coming days, except for the shareable auralization that's coming in a few weeks from now. Okay, that was the new auralization features. The last feature I want to show you is our new geometry processing algorithm. Now I'm going to go back over to SketchUp. This is SketchUp. Now, what Treble has required up until now is if you wanted to do a wave-based acoustic simulation, which is of course a more fun type of acoustic simulation, at least from my very biased opinion, then you would need sort of a quite perfect model to work with. It had to be, for example, watertight. So now I'm going to show you how we have sort of managed to relax the requirements on the geometries and still be able to do acoustic simulations on them. I'm going to go ahead here and import a particular 3D model, which I happen to know is not perfect. This is a model from a round-robin study. And I'm going to try to import it into Treble in sort of the old way. So I'm going to open the Treble plugin here and create the Treble folder. I'm going to pull the layers in the 3D model into geometry layer, and then I'm going to try to check that the model is okay using the old approach, which is sort of a locally implement, something that's implemented into SketchUp that runs locally on my machine. I check it here and it complains the geometry is not watertight. So I will then, what I could do before is I could click this button here where it would sort of highlight where in the model we have issues. For example, here there's a little sort of slit here that's an opening. It's not glued together. I could go ahead and fix that, and that can be a bit of a tedious process. I've always had the option of just uploading it as a non-watertight model and then be able to just run geometrical acoustic simulations on it. But if I wanted to do a wave-based simulation, then I would have to fix this. But now, with our new geometry checking algorithm, this can be automatically fixed. So I'm going to rerun the check. I just need to make some modification of the model so I can rerun it. I'll just rename this layer here. And then I'm going to try this cloud checking. It's still a beta feature, but will be launched very soon. So I'll check the model in the cloud. It takes a bit longer because it needs to send it to the cloud, do the checking, and then do the automatic healing of the geometry, and then return some information back. We're also working on making this faster, of course, but let's see. I'm expecting it to be done in any second now. Here we go. Now you see, no complaints about water tightness. The geometry has been fixed automatically. And then I'll just upload it here, create a new space, call it round robin, like so, and function 1 or whatever. Upload it. Open it up in Treble. And now I can run a wave-based simulation on this model. You will see that the geometry has been fixed here. So just a step in the right direction towards making the whole geometry process even more smoother than it's been before. But we're continuously working on making this even better, integrating with BIM tools and things like that, which are on the roadmap. So that kind of concludes my presentation, or this presentation of these many new features. I do want to make a note that it's less than 3 months since we had our last feature announcement webinar, where we were announcing a bunch of new features, surface receivers, new scattering modeling, 50% speed up of our wave-based solver, also speed ups of our geometrical acoustic solver, own sounds in Auralizer, many new things. Now we have all of this, and you can certainly count on that in, let's say, next 2 to 3 months, we will have another webinar with a bunch of new features as well. So there are many exciting things going on at Treble these days, and the sort of pace at which we are continuously improving the product has really increased. So that's very exciting. Last thing I want to show is that we're also putting out a bunch of new validation studies all the time. So here on our website, if I go to resources and validation cases, then you will see a bunch of really exciting, cool examples where we have been comparing Treble against measurements, against other simulation tools, and so on, and showcasing the added accuracy that Treble brings about. Okay, that was it for me. Thank you so much for listening. I look forward to the Q&A.